Hi, I'm Darshana Anand,
I'm Alekhya. My name is Chi.
and this is our MSE 2001 group project.
Hi! Now that we've made our strips, we decided to make some fun little shapes so we can test how each of those would affect our deflection. So to start off with basic shapes, we have like a circle and triangle, and then we decided to get just a little bit creative and we made a snowflake. So we're just going to test all of these with heat and see how it goes. So once we finished this experiment, we could see that as we predicted, the aluminum foil expanded a lot more than the paper, which is why we saw the warping. In terms of the strips, we saw the strips rise a lot more to a point when we could measure deflection up to 6 inches. And for the shapes, it was actually a fun experience to see how the shapes deflected because each one of them curved depending on how we cut it. For example, the triangle kind of squished together and the circle also like rose up on the edges.
So our observation is due to the fact that aluminum foil has a higher CTE than paper. That's why when we heat it up, the strip bends towards the paper side. And in this situation, the foil is under compression and the paper will be under tension due to the foil.
So once we did that, we decided to actually cross-check these values against actual data, and we saw that the coefficient of thermal expansion for aluminum is 24 times 10 to the minus 6 inches, like change in inches per Kelvin, and the one for paper is much lesser than that. The one for paper depends on what kind of paper you're using and what kind of materials go into the paper, but depending on the data that we saw, since we used regular printer paper, it was much lesser than aluminum, which is why we saw such huge deflection values.